Hey everyone, so this is going to be the first video for Chapter 6, and in Chapter 6 we're going to be talking a lot about alkyl halides and then something called nucleophilic substitution. Right, so alkyl halides, remembering that they are halogen species attached to carbon molecules, right, alkanes. The first thing we're going to do regarding them is sort of a little bit of review for naming, where we're going to introduce talking about stereochemistry with naming, and also how to name alkyl halides. So first, we're going to talk about naming with stereochemistry, which is very similar to everything we've done so far in Chapter 5, right, looking at our S configuration. So when we have a molecule that does have a chiral center, right, what we're going to do is whichever number carbon has a chiral center, we're going to be giving it a R or S configuration. So for example, if carbon number 2 had a configuration of R, it would be labeled 2R, and we put that in front of the name. And if we had a compound that was meso, right, it had a mirror plane going through it, right, it had a plane of symmetry, we would write meso in front of the name. So I'll go over some examples of that. So looking at this molecule down here, right, we can see that we have, right, this 7 carbon chain, and going through our usual naming procedure, we know that carbon number 3 and 4 are the carbons that have these substituents on them. Right, because this is heptane, and we always number starting from the lowest possible position, right? So number 3. And so now we have this sort of additional complexity now of, because we have a chiral center, we need to denote what the configuration of the chiral center is. So I'm going to erase some of these numbers here so we're not clogging up the screen. And so looking down at this first carbon, right, carbon number 3, we know that the highest priority groups on here would be 1, right, for this carbon right here, which is bonded to 2 carbons and a hydrogen. This would be our second highest priority, right, because this carbon is bonded to 1 hydrogen, or 1 carbon and 2 hydrogens. And then our methyl group is our number 3 priority, because it is just carbon bonded to 3 hydrogens. And of course we have our hydrogen on the wedge here, which is our priority number 4. All right, so looking at this, the priority goes counterclockwise. So we have a configuration of S, but because that hydrogen is on the wedge, we know that it is R, right? And so because carbon number 3 is what has the R configuration, we denote it as such in front of the name. And we do the same thing with the carbon center here. I'm going to erase the priorities, again, to make sure we have enough room to look at things. Right, so our highest priority here would be this carbon, right, because coming off of this is bonded to 2 carbons and 1 hydrogen. Right, and this is number 2, because going out from here, right, we see that we have a carbon bonded to 1 carbon and 2 hydrogens. But looking at this carbon here, if we go out, then we only have a methyl group here. So this is our next lowest priority. Of course, we have our hydrogen on the wedge here for priority number 4. So this time we have another counterclockwise situation, right? So this is going to be S configuration. Because hydrogen is on the dash, we don't need to worry about inverting anything. Right, and because, again, this is carbon number 4, we need to denote that carbon number 4 has that S configuration. So next, right, we know how to name with stereochemistry now. So let's look at naming with alkyl halides. I talked about this briefly in Chapter 3, but essentially it is the same exact rules as alkane nomenclature, right? But instead of treating it like a alkyl substituent, right, which we can't do, whenever we have a halogen, instead we treat it as a branch using the appropriate prefix. So a chlorine would be chloro, fluorine would be fluoro, bromine would be bromo, and iodine would be iodo. right? And there's no priority over alkanes in terms of numbering, right, or placement in the IUPAC name. Instead, we want to, right, still number the longest chain so it has the lowest overall number for its branches, and, right, alphabetically, we want to make sure things make sense too, right? So looking at this right now, right, cyclohexane, right, the question is, do we start numbering from the ethyl group or do we start numbering from the iota group? And we number from the ethyl group, right, going 1, 2, 3, 4, 5, 6, because E, right, comes before I alphabetically. So that's why we number it like this, right, going from 1 ethyl to 3 iota. Right, and I will leave the RS configuration determination up to you, but again, because we have chiral centers here, right, we have to denote them as such. So, right, for 1 ethyl, that carbon has to be S, and for 3 iota, we know that this chiral center has to be S as well, right? So we have to list it as such in front of the name of the molecule. So what we'll do in class is go over a few more examples of naming and try to make sure we have the RS configuration naming down and making sure we know how to appropriately name alkyl halides.